Okay, now for the type 2, errors, so for type 2, we have to have a p that's bigger than 2. So now let's do another one. So suppose now p equals, say, 3/4, and find probability we make a type 2. Okay, so this would be equal to probability y star is less than 10 given p equals 3/4. Okay? What is it doing? But this is, again, I can just use the binomial. This is going to be less than 10. This is going to be 1 minus the probability it's equal to 10, 11, or 12. And if p is 3/4, this is 1 minus 12 choose 10. 3/4 to the 10th. 1/4 squared minus 12 choose 11. 3/4 to the 11th. 1/4 and minus 3/4 to the 12th. Okay. We can do this by we can actually compute these. What do we get? We get 1 minus, I get 66. Well, this is going to be pretty ugly here. So you can see it's already pretty ugly. The whole denominator here would be 4 to the 12th, or 2 to the 24th power. Here I get 66 times 3 to the 10th, plus 12 times 3 to the 11th, plus 3 to the 12th here. And you might use in R, you can use the command p binom. So p binom would tell you what this is, right? It's a CDF. So this counts when y star is 9, 8, 7, 6 down to 0. So this also equals p binom. I want 9. This is like the CDF function. I want 9 here, and my n is 12, and my p is 3/4. So if you do this in R, I'll do it right now in R here. Let's see, I've got it, p binom. So I have p binom 912.75. I get 0.661. Well, this is probably too high for us to like very much, right? If even when p is up to 3/4, there's a 61% chance that y star is 9 or fewer, which would make me pick the null hypothesis. Whether this is acceptable or not depends on the test. So we have to talk more about this, I mean on the goals of the test. But I'm very distracted by the whether this is looking good. So I'm going to stop this one now, and I will try to get a nice clear picture for you on the next video. So we continue from here on the next one. We're still on chapter 10.2, elements of the test.